Hello, everyone. Thanks for joining today for an exciting session from Unravel Data Systems. I'm Prajakta Kalmek, and I'm working as a principal engineer at Unravel Data. And I'll be joined today by with Yusaku Sako, who is basically heading some exciting projects in data science team. So Unravel has a very strong tech background and a rich experience owing to the broad coverage it has in various technologies and cloud platforms. We are very proud to have served and trusted by our customers and our partners who value Unravel today as one of the most reliable and trusted vendor. So what is data ops? So data ops practices basically automate and provide continuous quality checks to bring speed and agility throughout your data analytics process. So we at Unravel basically understand the complexity and the challenges you face for every stage of the data ops cycle. Today, we provide solutions for end-to-end observability and real-time actionability. We go a step beyond from just providing passive monitoring using AI and ML to automate most of your data ops tasks. For example, we help you plan the infrastructure, the environment, and select the right stack and the topology for your cloud. We understand the development hiccups and provide solutions for the users to fine-tune their apps early on. Our solutions offer debuggability of data-oriented pipelines, which helps the user test the correctness and performance efficiency of your pipelines even before they go to production. We understand the challenges a user faces when trying to schedule a new workload, selecting the container sizes, and our softwares enable users to handle this process with ease. Our customers have used Unravel successfully to not only tune their apps, but also eliminate rogue behavior, or even to move some apps to a new environment at runtime. Finally, we create solutions to continually monitor your apps as they are running in production to find issues, to detect issues, provide fixes, optimize, to accelerate, and even to accommodate additional workloads. So today in this talk, we'll be showcasing some very cool and impactful use cases that you can use throughout the code, the test, the deploy, and operate phases of the data ops cycle. Specifically, we will show how using the Unravel API, users can customize their dashboards for every persona in the company, right from data engineers to executives. For example, using the Unravel API, developers, the data engineers, the data analysts, the data scientists, they can use to submit ad hoc apps with ease by detecting issues early on. We will also see a demo of how a scheduling assistant tool can be used by the platform team during their deploy phases to schedule new workloads. And finally, we will see how Unravel uses predictive analytics to provide operational actionable insights. So let's see how we can speed up the development. So we want to see how the day of our developer, John, is going today. So John very happily and hopefully submits a very simple query that aggregates sales by age. And he is expecting the query to run fast because he has done this several times before. But today, for some reason, the query is taking long and way too long. Once the query completes execution, John basically tries to debug. Hey, what was the issue? Why did the query take so long? And he detects that, one of my tasks suffers from data skew. But John knows a fix, so he submits the query again. But this time, apparently, it didn't work as well. So then he remembers that, hey, in the past, I had used a trick, like provided a hint for broadcast hash join, and that made it work. Maybe let me try that. But even after a lot of time, at the end of the day, John is still wondering, why didn't it work? Was the cluster an issue? Maybe my small table was not small enough, or maybe the timing was just not right. So let us take a look at why this process is hard, right? So developers today suffer from multiple issues during the development cycle. They face challenges and they try to figure out what went wrong. Sometimes they can even find out the root cause, and like, for example, my data was skewed on a particular column. Or they try to pull out some workarounds from the past and play around with the querying. But when things just don't seem to work, they start looking for clues. Maybe the query was not resource efficient. Or maybe the cluster was just bottlenecked and the user doesn't have a clue of what went wrong. There will be task failures. Contentions would have led to some slow tasks. So the key to your data ops success is how efficiently you adopt and implement the interactions between your people, the process, and the technology. So users like John today need tools like Unravel to bring out the data-driven insights and generate some key performance predictions, even before they submit the query as they code, right? So let us take a quick demo of how Unravel integrates the Unravel API with the Jupyter Notebook to help users like John to figure out whether to query or not to query.
Hi, I'm Yusaku Sako. I'm the head of data science at Unravel Data. And today I'm super excited to reveal to the public for the very first time how Unravel can bring you AI-driven actionable insights and recommendations for your big data apps as you're coding in your favorite IDEs, such as Jupyter Notebook. As you will see, this is very different from what happens today, where you need to jump around between different UIs and logs after your job executed to try to connect the dots and still not know what to do. So let's see this in action. So to connect this Jupyter Notebook to Unravel AI Engine API, all you need to do is install the Unravel AI package and import it as shown on the screen. And basically, you just need to make a single call to connect with the Unravel API endpoint and a valid API key. So let's do that. Now we're connected. And now we're ready to analyze Spark apps through this notebook. And to perform analysis, you use Jupyter Magic with double percent signs. This is called Magic. And for Unravel Spark analysis, we have a custom magic like this. And what you need to do is supply an optional ID, which is the variable name where the SQL query string will be written to for your convenience, and also days for number of days for analysis, as you will this will become clear to you shortly. So let's say that you have this SQL query where you have a join between two tables. So let's ask Unravel AI and see what's happening with this query. So I just submitted a request, and this is the API response that came back. And this is saying that in the past 30 days in this cluster, there were 17 similar runs of this query with the following statistics. The fastest one ran 34 minutes, the longest took 2.8 hours, and the median duration was 55 minutes with 100% success rate. So for this query, one issue was detected, and it was query slowness due to data skew. So the Unravel API analyzed and found that the join between these two tables, the fact table and the dimension table, is problematic because there's a data skew on the fact table. And so it came back with the recommended action to increase this parameter, auto broadcast join threshold, to 232 megabytes from the default of 10 megabytes. And it also explains that enabling broadcast join would counteract data skew, and it can speed up the query substantially. And how did Unravel come up with this recommendation? So let's take a look. So whenever there's an explain link, you can click on it, and it will reveal more information. So for this particular query, it found 17 similar query runs in the past over the last 30 days. And so the key here is that between the two tables that were joined, the smaller table, which in this case is global dimension, the data size was 202 megabytes maximum over the last 17 runs. And you can see it's hovering around 200 megabytes with 202 max. So the recommendation to increase this value is based on this data and plus some headroom to make it 232 megabytes. And so whenever there's a data skew problem and the smaller table is reasonably sized, as in this case, then broadcast join can help speed up your query. And that's what Unravel recommends. And you didn't need to know anything about this auto broadcast join threshold. You didn't even need to look at historical runs of a query. Unravel just found it for you and made this recommendation. So let's take a look at another example. So let's submit a request to the Unravel AI API, and it came back with this following result. So this query is a little bit different from the previous one in that, so we found 12 similar runs. In general, this query takes a little bit longer to run, but as you saw in the previous query, the issue found is the same. So this is query slowness due to data skew. But interestingly enough, the recommended action is actually different this time. So the recommended action is to enable adaptive query execution, and also to set skew join, adaptive skew join enabled. And why did it give a different recommendation this time for the same issue? So let's take a look. So what Unravel did was it took these 12 similar runs and again did a similar analysis where it looked at the data size of the smaller table in the join. And in this case, this table was a little bit bigger, as you can see in the past 12 runs. So in the previous example, the table size was 20 megabytes. And this time around, it's around 1.6 plus gigabytes. And this is much larger. And whenever you have the smaller table with data size this big, more than a gig, and your query has data skew, then adaptive query execution with skew resistance is recommended. And it should perform well in such scenarios. There's a caveat. So this adaptive query execution is a new feature in Spark. So if you don't have Spark 3, then you can't use these use these settings to enable this because it's not there. So in such scenarios, Unravel would automatically detect that condition and say, okay, adaptive query execution is not available. Then we'll recommend a different technique, such as salting, to counteract data skew issues. So, again, you didn't have to know anything about adaptive query execution or anything about broadcast join or the join and the smaller table data size. It just Unravel did it for you automatically and pretty much instantaneously. Let's take a look at another example. So this query is a bit different from the previous two, and it runs relatively quickly, but there's still some issues or definitely room for improvement. So a couple of issues were detected. One is low utilization of CPU resources. and another is low utilization of memory resources. And specifically, Unravel is recommending to increase Spark executor cores to 2 from the previous setting of 1, and also to decrease Spark executor memory to about 2.6 gigs from the previous setting that was used for the past runs, 4.5 gigs. And this explains that applying these recommendations will speed up your application while reducing allocated memory. Okay, so let's take a look and see how these were derived. In a similar manner, Unravel found 7 similar runs of this query, and actually looked at the executor memory usage and not just the container allocation max. So the line that you see in green, this is actually VM RSS from the executor. So in this scenario, there's only one executor. And the blue line shows the Spark executor memory setting that was used. And the orange dotted line shows the recommended new value for Spark executor memory. And this is actually derived in such a manner that these two setting changes work well in conjunction, meaning increasing the core size, but it's still calculating the memory to go well with it, and to manually come up with such combinations that work well against a multitude of factors involved is a difficult task and not an easy one. So as you saw in these 3 examples, we're radically changing the way that app development and troubleshooting can happen by bringing actionable insights directly into your developer environment.
So we just saw an exciting demo, and I just wanted to talk about how does Unravel basically do this, right? So Unravel basically exploits the fact that users like John, they issue similar queries, and multiple users who are sharing the cluster, they face similar challenges, right? And they often also repeat their mistakes again and again. So by exploiting the data from the same user and other users, Unravel basically gets a holistic view of what worked in the past when your query was executed and what did not. It uses this information to generate the key performance predictions as you code. So now let us take a look at the second use case of how Unravel helps users in the deploy stage to schedule new workloads. So it is very crucial to provide contextual insights to be truly data-driven today, right? So for example, users who want to schedule a new workload, they would say hey, I have tuned my query several times and I have tested it on the UAT cluster multiple times. So I know my resource requirements. So can I just check what is a good time slot where I can schedule the query, right? Or even a very pressing use case is users who want to generate a report by a particular time. Say, I want my report by 7 a.m. on Monday morning. And you can schedule it whenever you want, but I just want my report to be ready by 7 a.m., right? So it is important to contextualize whether it is a resource constraint or a time constraint or neither of them, right? A user might come and say that, I have a new workload that I need to schedule on this cluster. What is the best time? When should I start the pipeline for it to run efficiently? So how do we find the missing piece of this puzzle? Do we look at the cluster issues, maybe the tasks failures or the contentions or the memory issues? Or do we look at the query problems, like has the input data size increased over time? Is my query shuffle heavy? Or is it both, like, a user trying to schedule a shuffle heavy query at a time when, the cluster is known to have more network load? So Unravel contextualizes these insights by generating the predictive insights. Our algorithm basically works harder till it finds the right slot, or as I like to call it, till it times it right. So let's take a look at a quick demo of how Unravel integrates with the API to provide scheduling assistance. So if you see the screen, basically users can come to Unravel, select the cluster on which they want to say schedule, select the window for the analysis, and users will be able to see, what were the available vcores or available memory in the particular time slot. So what this heat map shows is the 7 days of the week and the 24 hours, and at every slot, what was my available vcores. So the user who is confident about, say, the resource requirements, say I want 10 vcores and I want, say, 16 GB memory, right? And my app is expected to run for 30 minutes. Can you recommend me some good slot to schedule it? So Unravel comes with the recommendation and says that, hey, maybe it is good that you can schedule the query at 4 p.m., right? You have the required vcores and memory. And the users can then click on a particular slot and also see, like, maybe I want to take a look at what are the other pipelines or apps that typically run in the same time slot to get me an idea of, who will I be running concurrently with. Maybe the user doesn't want to submit the query on Monday, right? He prefers a different slot. So he can click on the all feasible tab here. And then Unravel generates all the feasible slots in the heat map, basically where the user can schedule. And maybe the user can decide, like, hey, how about like I submit on, say, Thursday, because I have 2 more available slots after that. And even if my query is, spilling over or not finishing in time, I still have ample room for it to execute properly. So Unravel basically utilizes the cluster metric time series, the cluster statistics, right? And the query execution variability data, the resource profiles, the consumption history, to know when exactly it worked, like, when exactly your query was able to perform well in what circumstances and when it did not. Using this data, Unravel generates its predictive analytics. So apart from the 2 very cool use cases that we have seen, Unravel also generates operational and actionable insights. So we don't have time to do the demo for this today, but I just wanted to real quick show this screenshot where what we see here is a pipeline with multiple components. We see a timeline of each of the component, the input size for each of the component of the pipeline. And what you can see prominently here is like, hey, the pipeline was delayed. And it was delayed by about 26% above the average execution time. So when a user clicks on the insights that Unravel generates for this pipeline, right, they can see that, input read IO was actually 40% higher than the baseline model. And just right next to it, the users can also change the metric and see that, my query had a consistent input data size till now, but in this particular anomalous instance, it peaked and went way above, like from 2.8 GB to around 4.8 GB. So how does Unravel basically do all this, right? So Unravel employs an adaptive data collection strategy. The Unravel daemons collect information about everything in the ecosystem, right? Right from your apps, the pipeline, the containers, the system, the data sets, and so on. And it uses this data to build robust ML model, which generates query quality predictors and the cluster state indicators, which is then used by the Unravel API to kind of provide visualizations for every stage of your data ops. So in this talk today, what we have seen is basically 3 different use cases, which show us that, you can very seamlessly integrate the Unravel API and make it accessible to every single persona in the data ops cycle, your developers, your platform team, your executives. who can derive much more data-driven and accurate insights with Unravel. So just to recap, what does Unravel do, right? It detects issues as early as possible. And what does that mean for a developer like John? It just means that you come in happily, submit a query at 8 a.m. The query completes in a very short time. John ends up feeling very ecstatic and accomplished because he had a successful query execution early in the day. And it is a predictable execution based on his expectations. And finally, John finds the time and the opportunity to invest on the right things and to innovate and enjoy the rest of his day. So that is from all from Unravel Data Systems. Thanks for watching, and we'll be happy to take any questions.